add and subtract radicals, and rationalize the denominator. Example 1. We have some numbers here, and so we see that 32, the biggest perfect square that fits inside there is 16, and the remainder is times 2. 16 times 2 is 32. 27 breaks down to 9 times 3. 9 is 3 squared, that's the biggest square inside 27, and 36 is the biggest square inside 72, and this is what's left over. So you do that first, then you say the square root of 16 is 4, the 2 stays in. You use the parentheses so you don't forget the negative 2, and then square root of 9 is 3, and you still have the subtraction sign. Square root of 36 is 6, you still have the 2, you still have the plus, and square root of 2 is left inside. Then you have, you just clean this up, negative 8, rewrite that, 2 times 6 is 12, and then combine like terms. 12 square root of 2 minus 8 square root of 2 is 4 square root of 2, and minus 3 square root of 3, and they don't add because they're not the same base. Okay, rationalize the denominator. Square root of 1/2. You break that up as the square root of 1 divided by the square root of 2. So that's this. Then you multiply by what's necessary to get rid of the square root of 2 in the denominator. So if you hit it with a square root of 2 to the first power, square root of 2 times square root of 2 will end up being 2, so that will do the trick. So you multiply by 1 in the form of square root of 2 over square root of 2. The square root of 2 multiplied by 1 to give you the square root of 2. Square root of 2 times square root of 2 is 2. Okay, example 3, we have here 1 over the cube root of 2. This time, it's not good enough to multiply by just cube root of 2. That's not enough 2's to come out of the cube root. You need 2 2's of factors. So you multiply by this version of 1, and you have, that's the cube root of 4 up there. And down here, cube root of 2 times the cube root of 2 squared is the cube root of 2 to the third. And the cube root of 2 to the third is 2. So that one's done. Then you come over to here, 1/2 over square root of 3 over 2. This shows up in trig. So you would immediately just multiply by the reciprocal, 2 over square root of 3. Then the 2's just luckily cancel out and you get 1 over square root of 3. Then it's a square root, so you just need to multiply by 1 in the form of square root of 3 over square root of 3. Square root of 3 multiplies over to square root of 3. Square root of 3 times square root of 3 is the square root of 3 squared, which is 3. Then example 5, here's one here. What we do here is when we see a subtraction or an addition like this, whether it's variables under these square roots or 2 square roots, it doesn't matter. You multiply by the opposite sign that's in the middle, plus. That's called multiplying by the conjugate. The conjugate of 1 minus square root of 2 is 1 plus square root of 2, and vice versa. You just change the sign to the opposite, because good things will happen when you do that, and then make it be multiplying by 1. There's a big giant 1. Then you multiply over, but you should do it with parentheses. Multiply this over in parentheses. Then use the FOIL method on the numerator and you get this. Square root of 3 times square root of 2 is square root of 6. Use the FOIL method on the bottom. 1, 1. The outside is square root of 2. Inside is negative square root of 2, that's why you did it. And square root of 2 times square root of 2 is 2. And you have minus times plus is minus. So right there is exactly why you multiply by the conjugate, in order to get this minus plus or plus minus thing to happen, so these square root terms cancel out, and you're just left with 1 minus 2 is negative 1. and you would just distribute that in as -1 times this, and it would change the signs.